Hey everybody, today we're still in our functions unit and we're going to be talking about function composition and composite functions. So in math, we know that we have four basic operations: addition, subtraction, multiplication, and division. We saw how we can apply these operations to functions both algebraically and graphically. However, when we study functions, there's one more operation that we will study, and it's called function composition. So the notation, okay, first of all, we have to talk about the notation. The notation for function composition, and in words we say like f composed with g or f of g, okay, that's how we read it, is f of g of x, okay? And it's that little open circle, okay? But what I usually do when I'm dealing with function composition is what I usually want to do is rewrite it right away as f of g of x. Okay, that it just is how we evaluated it makes a lot more sense. And you may remember that little open circle from your geometry class when you were doing transformations. So hopefully you remember a little bit about what composition is. In order to solve a function composition, you need to work from right to left. Okay, so in other words, we're going to start by plugging into our inside function, g, get an answer, and then we're going to take that answer and we're going to plug it into our outside function, which in this case is f. So the first way we're going to evaluate these is by looking at our table of values. So in this given table, I have a bunch of x values, I have my function values, f of x, and I have function values for g of x. In part A, I want to evaluate f of g of 1. Right away, I like to rewrite that as f of g of 1. Okay, so now it's a little bit more obvious. I'm going to plug 1 into g, get that answer, and then plug g into f. So when I evaluate and I plug 1 into g, my output is 0. So g of 1 equals 0. Now I'm going to take 0 and plug it into f. And f of 0 is 5. And that's your answer. And that's how easy it is when you're evaluating from a table. G of f of 3. I might do this one a little bit quicker. So f of 3, again, going to your table, I go over to the 3 of my x's. I go to my function f. F of 3 is -1. Now I'm going to take -1 and plug it into g. And g of -1 is 0. Okay. Not everything is going to stay this easy though. Okay, the table is very easy to evaluate from, but we also have to know how to apply this to actual functions themselves using the algebra. So let's say we have given f of x equals 2x squared minus 3 and g of x equals 4x. We want to find f of g of 1. Rewrite f of g of 1. Step 1, right? We're working inside out. I'm going to plug 1 into g. And g of x is 4x. 4 times 1 is 4. And now I'm going to plug 4 into f, which is 2x squared minus 3. And you could do a little math there. You're going to get 1632. Our answer would be 29. G of f of 1. Ooh, I scrolled too far. G of f of 1. I'm going to plug 1 into f first. -1. And now I'm going to take -1 and evaluate that in g. And in my last example, let's see if I can't get it to stay on the screen together. F of -2. So I'm going to plug -2 into f, get my answer, and then plug that answer into f again. So you just have to learn how to read the notation and follow the directions. F of negative 2, 2, negative 2 squared. 4 minus 3 is 8 minus 3, sorry, is 5. And now I'm going to evaluate that again. F of 5, 2x squared minus 3. And that's going to equal 50 minus 3, which is 47. Okay. So when we evaluate, okay, it's kind of, our functions are like a machine, f of g of x. Okay, start with the inside, move right, right to left, inside to outside. Okay. In this course, we're also going to be asked to find the composite function. The composite function. Okay. So now when we find a composite function, we're really writing our function in terms of x's. So here you're going to plug the entire rule of the inside function into the x's of the rule of the outside function. Your answer, it can be a number, but usually it's not going to be a number. Instead, it will be a new function. So you will have x's in your answers. Be aware of that. Now, to find the domain of a composite function, because it is something we talk about in this class, okay, after you get your new function, you're going to find the domain of the inside function. You're going to find the domain of your final answer. And then you're going to combine both of those domains together to create the domain for the composite function. In example 1, f of x equals x plus 1 and g of x equals x squared plus 4. We want to find f of g of x. So what we're going to do is we're going to replace g of x with what it's equal to, with its rule. Oops. So in this case, we're doing f of x squared plus 4. Now, every place I see an x in f of x, I'm going to replace it with x squared plus 4. So if f of x is x plus 1, and I'm actually going to write it like this first. You see how I just put a set of parentheses there? That's my x, and that's what I'm going to plug in x squared plus 4 for my x. And now I'm going to simplify it, so f of g of x becomes x squared plus 5. If I want to find the domain of this function, I consider the domain of my input function. The domain of my input is my g of x, which is all reals. Then I look at my end result. And you don't have to use the input in the end. I like to just use it to, to keep myself organized. My end result is this guy here, x squared plus 5. The domain of a quadratic is all reals. So the domain of my overall function is all reals. Now, when each of your functions, f of x and g of x, or whatever we're going to call them, when the domain of the original functions are all reals, your end result will always be all reals. So, just be aware of that. Now I want to take a quick second and just kind of explain what we just did. Let's just say we go back up to our two original functions, f of x and g of x. And I ask you to find f of g of 2. Let's go and do it like we would on the previous page. Let's take g2, and we're going to plug it into g first. And we would get 8. And then we're going to take 8 and plug it in to f. And our overall answer is 9. So now, what this composition of functions did, what this did was it created a function where we can get to the the final answer in one step. And so now instead of plugging into 2 steps, I'm going to use this rule, the rule I made. And as you could see, we get the same answer. So when we do a composition of functions, we're really taking the 2 functions and smushing them into each other so we can get someplace in one step. Now, that does not mean you have to write a composition every time you're asked to do something, but you should know how to do it when you need to. For example B, f of x equals 1 over x plus 2, and g of x equals 4 over x minus 1. We want to find the composite function f of g of x. So be real careful. You want to make note of what function is getting plugged into the other function. So if I'm doing f of g of x, I'm taking g of x, which is 4 over x minus 1, and then I'm going to plug it into f. So I'm going to take the x value in my function, and I'm going to substitute in 4 over x minus 1. So 1 over 4 over x minus 1 plus 2. Now we have to simplify this guy. And this is why we did that algebra in the beginning of the year, because now you would see that this is a complex fraction. So we're going to go ahead through and we're going to multiply each term by x minus 1. And I'm a little sloppy. So f of g of x, in the numerator, I get x minus 1. In the denominator, my x minus 1's cancel. And I'm left with 4, this is a plus, 2x minus 2. I'm going to just go kind of one more step here, make it nice and clean. X minus 1 over 2x plus 4. Two x plus 4, 2x plus 2. Thank God I caught that mistake. It's perfectly acceptable to leave it just like this. Now we want to describe the domain. So my domain of my input function, go back to the function that you plugged in originally. So the domain of your input function, set the denominator equal to 0. X can't equal 1. Okay, we just finished talking about domain, so I'm expecting this to be fresh in your mind. The domain of my end function. Now I'm going to go to my final function down here. To find that domain, I set the denominator equal to 0. These are easy enough to solve in your head, and the denominator 0 when x is negative 1. So x can't equal negative 1. So my overall domain for this function, and if you want to be really official, x belongs to reals, x can't equal 1, x can't equal negative 1. Now, I'm going to show you for this example, because I may or may not, we don't know with assessments right now, you might wind up getting a multiple choice question. So I'd like to show you an alternate way to write this using function notation. So using function notation, if we wanted to explain this, so the set of all reals excluding 1 and negative 1 means I'm going to start at negative infinity, go to negative 1. Then I'm going to use all x values between negative 1 and 1. Notice the parentheses. Okay, my endpoints are not included. Then I'm going to use all x values from 1 to infinity. Okay, so this is 2 different ways to represent this same domain. Let's look at part C. Part C, if f of x equals 1 over x plus 2 and g of x equals 4 over x minus 1, giving you the same functions, but this time we want to find g of f of x and state its domain. So I'm plugging f of x into g. So every place I see an x in g, I'm going to be replacing it with 1 over x plus 2. And now we want to simplify this guy. Once again, I expect you to know how to simplify a complex fraction. So we're going to multiply each term by x plus 2. Four x plus 8 in the numerator. 1 minus x minus 2. Remember, we're going to distribute. So g of f of x, once I simplify it, becomes negative x minus 1. If you were to actually look at this, like look up this answer in a textbook, the textbook would probably pull that negative out front and write it like that. All you're doing is factoring that negative. But I'm okay with you guys leaving the answer just like this. Totally fine. Now let's work on the domain. My domain of my input. Okay, so I'm looking at this right here. X plus 2 equals 0. I could see very easily x can't equal negative 2. The domain of my end result. Go to my end result. I'm going to use the one that I did not simplify. And here, since there's negatives, it might make sense to do it x equals 1, so x equals negative 1. So negative 1 makes the denominator 0. So I have to exclude that from my domain. Overall domain, x belongs to reals. X can't equal negative 1. X can't equal negative 2. I'm not going to bother writing it in interval notation, okay? But just be aware that that is a way you can express it. Last question I want to actually go through with you today is sort of an application type of problem, okay? So how can this be used in the real world? Volume V, measured in cubic meters, of a hot air balloon is given by the function V of r equals 4/3 pi r cubed. If the radius is modeled by the function r of t equals 2/3 t squared, find the volume V as a function of time. So imagine this, you have a hot air balloon and you want to measure its volume, but instead of like climbing up there and having to measure its radius as an input value, we want to be able to find the volume by plugging in time. Okay. So what that is making us do in this problem is we want to find V as a function of t. So we need to plug r of t into V. This notation tells me to, every place I see an r in V, I'm going to replace it with 2/3 t squared. So I write down my function, 4/3 pi. Now I'm going to substitute in for r, and that gets cubed. 4/3 pi r cubed. Now we have to clean this guy up. So we have to use our exponent laws. 2 cubed, 8. 3 cubed is 27. T squared cubed. Multiply your powers, t to the 6th. Now we're going to do one more little short cleanup here. 4 times 8, 32. 3 times 27, 81. Pi t to the 6th. So you could now have a function, right? This is actually V of t. Okay, we can get the volume by evaluating it by plugging in time. As of right now, I'm done with the actual lesson of the day. If we were in the classroom and we had time, I would ask you to find, they give you these as practice problems. I'm going to work through them. So that you have something to look at, but I'm kind of not going to talk. I'm just going to kind of do the math and work through them. And if you'd like to, you could follow along. If you want to stop the video, try them, and then check your work, that's fine. Composite function and domains for each. G of x. I may talk to myself while I'm doing it. Okay. 2x squared plus 3. So I'm plugging. When I look to find the domain, that domain is all reals, that domain is all reals. So there's really not much work with this one. And for example 2, so there is my function. I have 2 rationals, so I'm going to have to be careful. There's my inside function, domain of inside. X can't equal 0, domain of end result. X can't equal negative 2/3. So my overall domain, all real numbers. And there we have it, okay? Thank you. And we will see each other soon.